Today, we're going to dive into the essential language of aviation, the special abbreviations that keep the entire global system running like a well-oiled machine. So let's jump right in. Okay, I want you to imagine something. You're a pilot, maybe an air traffic controller or a dispatcher. Your job depends on getting critical, time-sensitive information, and you get an official notice, a NOTAM. That's short for Notice to Air Missions. And this is what you see. Just a string of capital letters. At first glance, it kind of looks like a secret code, doesn't it? But this is no secret. It's the official language of the sky.
So can you translate that sentence instantly? Because if you have to pause for even a second to think about it, you can miss a critical update to a procedure or a major change at an airport. The stakes here are quite literally sky high.
Now, this whole system isn't trying to be cryptic. It's all about two things: efficiency and safety. In a worldwide industry where every single second counts and there is zero room for confusion, information has to be compressed into a universal format. It's designed for machines to process instantly and for humans to understand immediately, no matter what language they speak on the ground. So here's how we're going to break this all down today. We'll start with the where and when, then look at the data networks that connect everything. After that, we'll get into the official documents themselves, and finally, we'll pull it all together so you can see the big picture. All right, first up, the where and when. Let's nail down the absolute basics of how aviation defines physical space and time. So let's start with ADR. It stands for aerodrome. Now, this is just a catch-all term for any place an aircraft can take off or land. It could be a massive international airport, a tiny grass airstrip, or even a helipad on a building. In any official plan, the ADR is ground zero, the starting point. Next up is ADT, or actual departure time. And let me be really clear here. This is not the time on your ticket. This is the exact real-world moment the aircraft is off blocks and actually starts moving away from the gate. It's the moment of truth in the operational timeline. So why is this one little timestamp such a big deal? Well, think of that single piece of data as a ripple in a pond. It spreads out and affects the entire system. ADT is absolutely crucial for tracking the plane's flight path, for coordinating the next steps for crews on the ground and in the air, and for analyzing what might have caused a delay. It's a small acronym with a huge impact. Okay, now let's zoom out a bit with AFI, which stands for the Africa Indian Ocean Region. You see, the International Civil Aviation Organization, ICAO for short, divides the entire globe into these operational regions. And knowing what region you're operating in is critical because, while the language is standard, the specific rules and procedures can definitely change from one region to the next. And the last one for this section, AGL, which means above ground level. This is an aircraft's altitude, but it's measured from the physical ground directly beneath it. This is incredibly important when you're flying over, say, a mountain range. Your height above sea level could be thousands of feet, but your height above that mountain peak, your AGL, is the number that really matters. All right, let's keep building here. We've got the where and the when down. Now let's look at the digital networks that carry all this critical information around the world. Think of AFS, the Aeronautical Fixed Service, as the Internet of Aviation. Seriously, it's the massive underlying communication infrastructure. We're talking the fiber optic cables, the satellites, all the systems that physically connect every airport, every air traffic control center, and every airline operations hub on the planet. So, if AFS is the internet, then AFTN is like the super secure official email service that runs on top of it. AFTN, the Aeronautical Fixed Telecommunication Network, is the messaging backbone. It's the system used to transmit flight plans, weather updates, and yes, those critical NOTAMs we talked about earlier. Okay, so we have the places, the times, and the networks to send the messages. But what kind of information actually travels through these systems? Let's dive into the official docs and services. Now, at smaller airports that don't have a full control tower, you'll often find AFIS, the Aerodrome Flight Information Service. An officer on the ground provides pilots with all the essential info: wind speed, runway conditions, other planes in the area. But, and this is the key, they only provide information. They do not give commands. And that brings us to a really crucial difference. AFIS informs. They give pilots the data, the situational awareness, so they can make their own safe decisions. Air Traffic Control, ATC, on the other hand, controls. They issue mandatory, legally binding instructions, like cleared for takeoff. It's the difference between information and instruction, and it's a vital one. Hey, remember that confusing sentence from the start of our explainer? Well, this is the AIC part of it. An aeronautical information circular is like the official bulletin board of aviation. It's used for things that are important, but not drop everything right now urgent. Think of it as a heads up on future policy changes or technical explanations. And finally, we have the big one, AIP, the Aeronautical Information Publication. You can basically think of this as the master rulebook for a country. It's the official document that contains all the permanent information a pilot could ever need. Detailed airport layouts, instrument procedures, airspace boundaries, radio frequencies, everything. For a pro, knowing your way around the AIP is absolutely essential. So, we have covered a lot of ground. We've defined locations, tracked time, explored the data networks, and reviewed the official documents. It's time to bring it all home and see the whole system in action. So let's do a quick recap. We've got ADR, ADT, AFI, and AGL. That's the physical world. We've got AFS and AFTN, the digital networks that connect everything. And we have AFIS, AIC, and AIP, the services and documents that give the entire system its structure and rules. When you boil it all down, this whole complex world is built on 3 simple core principles. The first one is this: the language must be short. In an environment where every second counts, there's just no room for long-winded explanations. Communication has to be incredibly concise. Second, it has to be absolutely precise. There can be no room for ambiguity, no chance of misinterpretation when you're dealing with safety. Every single term has one and only one meaning. Period. And finally, and maybe most importantly, it must be global. A pilot from Japan has to understand a controller in Brazil instantly, without a single moment of hesitation. This isn't just a collection of codes. It's a truly universal language of safety and efficiency, spoken in abbreviations that connects our entire world through the sky.